so start right now.
Alan wants me to work on his bike motor, so I had to clean my bench off. So it's only taken how long?
I've been a hang around here at Tatro's for nigh on to 2 years.
You never seen this bench clear.
And you know what? We're ready to work, man. Look at this. You folks that are real critical of Keenan Tatro here and his cleanliness practices at Tatro Machine are going to see a new era. Watch this.
Look how much.
Look at this shit.
Actually, there's an actual workbench here.
Yeah. All right, now what's next? We usually draw file a surface, right? Only if there's nicks.
We actually have a real motor here.
He's ignoring me, but that's okay. All right. But mocked up, you call this a mocked up motor, right?
Yeah, it's not blown up, it's mocked up.
So what's in it now? Pistons, crank, rods.
Yep.
And what's the difference here with this pop-up piston as opposed to the flat one?
It's a dome piston, this is a flat top piston.
Well, then normally they wouldn't be like that, correct?
So we're getting ready to work on some real Harley motors, so we're going to work on some 45s.
1943 on the cases.
Alan wants me to get going on this so he can get his motor ready to go.
No, I want to learn.
He was so impressed with how the military bike was drag racing so nicely.
Well, that was impressive.
So this is your stock valve here.
All right. Okay.
Alright, so this here is a stock piston. So usually it stops about there. But there's something wrong with this motor, it goes up to here.
Uh-oh.
There's something defective about it.
Or it's got a stroke or crank in it.
Maybe that's the problem.
Ah.
Now this one here is a modified piston, so see it just pops up, it doesn't go past the surface.
Oh.
Then
Yeah,
somebody,
but what's going on here?
well, it's called a mock-up.
Oh, okay. Just asking.
We're making parts.
Just asking.
Okay, now here's some valve seats to use. So we got stock size for stock valves and big ones for big valves. So this appears to be the one for the stock. This here might not work for that one. So
what's our goal here? We're hot rodding this engine, right? Or is this R&D? We're gonna try to
R&D.
Okay.
So that has to go into there, and that's going to go over there.
Now you think about this as you're going, or you?
I see, because all I do is think, instead of sleep, I think about shit like
Oh, I know you do. And that's what I'm
now
saying.
here is a K model intake manifold. And where's my bag of parts?
K model is Y opposed to WL.
Right, that replaced this bag.
Oh, look how nice that is.
So this here is a panhead intake nipple.
Okay.
And
Thread in.
somebody accidentally
Oh wait, I gotta get some light here.
modified the ports in here, and now that fits on there like that. So that has to be welded in. And this one here already has one sitting here. So this one must be the one for the other side. So now that has a bigger hole. Now, if you wonder why my 45 military bike runs so good, this is the size I put in that thing.
Okay, you got something to show the folks comparison?
It's a lot smaller than this.
It's a lot smaller because we hogged mine out and just cleaned it up, and it's wow. Look at that.
So anyway, that goes in there like that.
So we're trying to put more fuel.
And this takes a 4-bolt linker, which is this size, instead of a 3-bolt, which is about that big.
Okay.
Now, if you want to know how much bigger it is, this is the intake valve, and it's not supposed to fit through the port.
And it almost does.
Yes. So that's what we're doing here.
So what kind of horsepower are you going to get?
And over here somewhere, we got parts written down. See, in case you wonder where the parts are at,
Oh,
they're all over the place. And you wonder who made the parts? I'm not sure who made them. But, somewhere around here.
Light green to red.
Okay, we're
record.
back live. Alan was recording like Fred does, and it goes off when you're not recording. Anyway, I was over here digging some junk out of over here. I don't know if he caught that or not. But
I
here you
did.
go. So here's some valves. Now this is out of a Ford 4.6 liter V8. This is out of a 1932 Harley 45.
All right. So what are we looking at here? Valve stem's smaller.
So this is what you get to make parts from. Obviously, this is not a very good application for this because it's too damn small, too short.
All right. We're looking for big.
So we want something bigger.
All right.
So here's another valve here. Now this is a knife-edged one here.
But 45, right? Stock.
Yeah. Now here's a stock valve guide. So this is a little loose.
Well, here's just a question. The longer the stem like that, you start twisting up the RPMs on it.
This must be the petcock I use on one of my race bikes.
Is that what you're interested in? Do you want a long stem like that?
You have to have a long stem because the valves are...
Well, I understand, but I could see right there, there's a weak point because the
there's your
stem...
lifter's way down there. It takes a long valve, see?
Yeah, all right.
And if you put a little short valve in there, you have to have a lot of lift before it hits.
Yeah, okay. Well, it's a funny looking motor without the covers on it.
Well, this here is a part that I'm using. Here's your stock valve springs. Not very heavy duty. Yeah.
We'll be back. Okay, now we're talking. Look at these valves.
That's a little bit bigger than stock.
Now, what are those out of? What's the application?
Blank,
Yeah, blank. Wow. Can you cut this keeper edge in here?
if we need to.
Aren't those harder than harder steel?
There's another valve, blank, see, no end.
Who builds blank valves?
Those are Manleys.
Will they build you a blank valve to your specs?
You know, here's a small block Chevy, 350. So that's a Chevy valve. This is probably a severe duty. This one here is another blank. These are Kibble white blanks.
What would a guy request if he was ordering blank valves?
So see, these are custom made. This is a blank valve. See, there's no end.
Yeah.
This is a finished valve. See, it's made for something.
So in other words, you could notch it and cut it to length, correct?
Right, I do what I want with it. So the problem is though, these are too short. See,
Oh yeah, way too short.
so you can't use Harley Davidson crap valves. They don't work. But we can use stuff like this. That's a little bit bigger than stock.
Oh wow.
Now I think that's about the right size.
Look at that. Wow. Yeah, but look at what you got to do up here.
See, it's right on the edge of the cylinder. That's how my race bike is. If you look at my
It's
KR.
right to the cylinder.
Yeah, it's right on the edge of the cylinder. It's perfect.
Wow.
That means that's the correct valve for a flathead. The only problem is a bigger valve seat. We can fix that.
And you can fix
We have
that.
bigger valve seats. Okay, so this is a little bit big valve. It's long enough though. That's the key. It's long enough. Okay, so these here are two other blanks. This is a finished valve. This is a small block Chevy. And it's too short.
Yeah.
Because right now that cam's up in the air right now.
Right, right.
It's too short. So small block Chevy's not good either. So now we're down to just blank valves. So this here, if you notice, we have two different valves here. These are 11/32. These are probably 5/16. These are 7mm.
You like a bigger stem, don't you? Thicker
Thinner
stem?
stem means more power.
Thinner.
Because see how the air has to flow past that stem to get to the port.
Okay, yeah, that makes sense.
So the bigger the hole blocking it, the more it plugs that hole up.
Okay.
The trade-off is in reliability. The bigger stem will wear longer.
Right, right.
It's a trade-off.
All right, so what about guides? What do we do for guides?
These are the valves that my valves are made from. These are the blanks that they sent me to let me know if they're long enough. Now these are extra hard right from here up. So as long as you don't make the valve shorter than right here, you have a hardened cap on the end of it, so you don't have to put a lash cap on it, which is a hard surface. And they can cut these down to whatever you want and make whatever you want. So then we go over here to the other parts pile. These are custom valves for everybody. And then we have custom-made valves for Tatro.
What's a valve like that cost?
So there's a custom valve for Tatro.
And Manley will do that at your request?
Yes. Now the problem is, see, that blank is too small.
Yeah, it's already too small, undersized.
So you know where that came from?
Nope. Oh, they made it off of that.
They made it from the intake valve.
Oh.
because you have limited sizes. I think it's only 1.6 inches. So if you want bigger, you have to
So
go
they
bigger.
went too small though.
Well, you have to cut it down to a big one. So this particular one is 1/675. So this is 50 thou bigger than stock. Stock is 5/8. This is 75. So this is 50 thou oversized, and it's the small stem. So this is the racing valve. And that goes in the racing hole. There's another one. Got two of them. What's this one? This one's the same thing. So these are the custom-made ones for my hot rod motors.
So after you get dialed in what you want, you can call them and have them send you a run of them, or what?
And you make stuff. Okay, here's special parts. So you can't run a stock valve spring, you got to run something different. So here's a valve spring. Heavy duty. Where's that little piece of crap on the head? See the
Oh
difference?
wow, look at that. Boy, you don't realize all that's involved here till you actually start seeing just how antique the original shit actually is.
The valve guide. So stock part means you put the valve guide goes in there, that goes there, that goes there, and that crappy stock valve goes in there like that, and that's how it works.
Right.
Okay, well, we're not using this. We're probably not going to use that. We have to use this, and we ain't using that. So we have this. So what are we keeping? Well, we're going to use this here and this. So that's what we're going to use. And then we want to reuse this. So we got to find a spring that will fit inside of here. So, oh shit, there's a spring.
Look at that.
Fits right in there, look at that. Seal in there. There it goes. So that fits inside the stock cover. And voila, we got parts that fit stock.
All right. Now what about valve guides?
Okay, so now we got to come up with other parts to make things work. So now we got to come up with collars and keepers to go on to hold the spring on. Well, this is kind of an odd size, we don't have it. So, there's a before and after.
Did you cut that down?
Yes. Manly doesn't want to make these unless I order, a couple hundred of them. So the demand's going to have to be higher than a couple motors. So there's what you make it from.
Wow.
Plug fit. That sits on top of that right there. Goes there.
Oh, I see.
See, this doesn't fit on this guide because I'm not going to use these.
Right.
Evo. Twin cam. So this is two different sizes, see?
Mm-hmm.
So this is, see, it doesn't fit. That one does. So this is 5/16.
So you would hone the.
This is for 7mm, which is this one. See?
Oh yeah, look at that.
So there's our guide for our small stem. So now we got a racing size valve and all that. Now, where's my, this here is made to fit on here, see? See, it's a nice tight fit.
Mm-hmm.
It's made for this application, not this, because I'm not using big ass valves. So look at the difference in hole size between those.
Oh yeah. Wow.
Okay, so you have to cut that down from that.
All right, but that's not a big problem.
Yeah, I forget which bag that came out of. That's a spring. So these are the numbers of the parts. So you don't want to lose them. Okay, then we got keepers for 7mm. We got keepers for 5/16. Two different keepers. Upper collar, same thing. Have to make it.
After, before. Beautifully done.
There you go. So that's not a press fit, but you don't want clearance. It's only got got about 8 thou clearance. You don't want the spring walking around on you. Now this doesn't work on this size, it works on the 5/16. So you make different valve.
Tatro, don't ever listen to any of these guys telling you don't know what you're doing. You put more than an hour or two of thinking into this thing.
Well, this project's been going on for 5 years. So.
Okay, but now we're gonna do it.
So now we got 625, 980, 900. So these are the racing sizes. So that's a 980 intake valve. This here's a 900 valve for the 5/16. And this here's 5/16 exhaust.
Oh wow, look at that.
So that's a 1/900 valve. It's right there.
Look at that. And the right length and everything. Wow.
Yeah, pre-made.
Yeah, very nice.
Now we went to a radius keeper instead of a regular stupid one. So you have to come up with a 5/16 keeper, which is over here. This was a 5/16 collar. So we got our base. I can't put the 5/16 guide on here, but you make the whole combination of parts here. So that goes in there. And you got your bead keeper. See, it's got a bead on it.
Yes.
So it bites in really hard.
I see.
It doesn't look any coming out. And it pinches in like it's supposed to.
Oh yeah.
See, there's no stupid Harley fitment. It puts in there like it's supposed to.
Right.
So there's our setup there. And then it all fits inside of our stock cover right there. And then obviously it fits in here like it's supposed to right here. And all of this stuff goes under here.
God, I like that sound when that drops in there
So
like
now
that.
all I got to do now is just make up the spacer to compensate for the difference in length between this and that.
Okay.
That's all I got to do.
Simple for you.
That part I haven't made yet. So now all that stuff is done, and you got a racing set of, you got basically full race parts to put in your bike. So now we're doing a stroker motor with racing valves, big ports, big carburetor, but we're still using a stock linker, so it'll all look stock. Stock
Right.
air cleaner bolts on it, so it all looks like a stock bike, just like my military bike.
Right,
it looks
right.
stock, it ain't stock.
But it ain't stock.
It's stock. Now these are the racing valves.
Look at how big that son of a gun is. That's really something.
So there's your two racing ones. And then your street ones are over here, 5/16. These haven't been opened yet.
What kind of steel is those made out of?
They got two variations. You got the severe duty on the 5/16.
Because they're beautiful valves.
So it's the second best valve. They got the best one's the Inconel. This is the second best, severe duty. The other one is a Racemaster material because they only have this length in the Racemaster material with a small stem. So I had to drop down one level on quality on the race valves from the street valves.
Now, are those forged or machined or what? How do they make something like that?
They're all forged.
They're forged.
It's all spun forged.
Wow.
You spin a lathe and you squeeze it inside of a mandrel and
Boy.
takes a piece of rod and mushes it out. So you got your two different valves. So you got your racing setup and you got your street setup. And the difference is this head size. Look how much bigger it is.
Yeah, but not a lot from racing to street.
So this one here is the race one. That's the race one. This one is the street one right here. And that's the street.
So you could still get some pretty respectable performance out of the street one, right?
This is a 1/900. Now the KR and WR, the biggest valves they had were 1 7/8. This is 25 thou bigger than the biggest thing Harley ever ran. Same exhaust size. Now this here, if I want to cut this down to a different head, I just machine it down on my lathe to a different size.
Right.
Or if I have time to, I just tell them make them smaller sizes.
Okay.
So right now we're doing a big port, all that, big stroke, and got some decent cams, so it's all going to be run with the bigger valves in it. So that's how the motor's going to be when you're all done. This is my mock-up motor, so this is just all playing around stuff. So this is how all this goes together. This stuff isn't just a bolt together application.
No.
It's not a kit.
So are we taking orders on building these for people or what? Is that something we do in the future or what?
It's going to be expensive.
All right, so
Now, right now, this here is a dome piston, which I'm working on a dome piston design. And then I got the flat piston, which is the other one. The other stuff I was playing was on down at the lower end. What you don't notice is there's a Sportster crankshaft in this motor. That's a Sportster sprocket sitting on there.
Huh.
That's not a 45 crank in here.
Yep. So when you're going through tech, you just keep your mouth shut pretty much, huh?
They don't need to know.
Good, look at that little piston.
Okay, so that's the stroker piston.
Hey, we usually,
Now look at the crank, see how the crank fills the hole in.
oh, good God, yeah.
Cut the stupid windows out of there.
Now, how big bore over are those cylinders?
Okay, now this here is a stock piston that I cut the bottom off to get more room. Yeah, I'm here.
Tatro. Hey, hi.
Hi there.
Come on in. We got a visitor.
We got visitors.
Hey, hi. Smile for the camera. That's a pretty smile. We like it. How are you, sir? Good. All right, you want to shut here for a minute?
So anyway, there's your 4 3/4. I mean, a 4 5/8 stroke in this thing. Not quite as long as my military bike, but this has Sportster rods in it, so it's got the big rods in it.
So we're building strength and stroke.
So you can run the piss out of this motor all day long. Now this one has a Timken bearing in here because it's got that in there. That's what I was making this here for.
Right,
And that was being made from this piece right here.
right. Stock.
So this is the insert that goes in the case to put the Timken bearing in it.
Mm-hmm.
So this part here is what we'll be keeping, be some of this out here.
Mm-hmm.
But for now, the motors I'm going to do right now, I'm going to use a stock main shafts and put special thrust bearings in there, and then run the Sportster rods and stuff on the outside.
Okay, wow.
So a little bit different. So we'll come back, we got more work to do
All
here.
right, nice. Boy, there's a lot to this, huh? Yep, nice stuff. Be back.
More junk. Alright, so we're working on the cranks here. Right, so this one here has a full Sportster crank in it. So that is not how I'm going to be doing these next two motors.
So you got, what, a run of 8 motors you said you're going to do?
Yeah, I wish.
No, I thought you said 8.
I don't think so.
Okay, I don't know. How many you think you got? 2 or 3?
How many pistons I got?
Well, what? How many in a box? 4? So you got,
3 different ones.
all right.
These are all these are custom made, all different sizes.
There's
So we
the
have
rings.
special rings.
Wow, look at that.
And we got some non-stock looking piston parts.
What's the turnaround time when you order something like that? Boy, those are beautiful.
8 to 12 weeks, 2 to 3 months.
And where's Arias at?
Up in LA.
L.A. A lot of good things come out of L.A.
There's
Oh,
your-
look at that.
This is your stock piston that's been shortened. This is your modified stroker piston, and this is the new stroker piston.
Wow,
A little different looking.
quite a bit.
And I made them for stock pins. If you notice, they're the same height. See?
Yeah.
Because this is cut for stroker already. This one here, obviously, is not stock. So that's how much less than stock you need. See?
Same number of ring grooves?
Yeah.
Are they stronger? Turn them over. Let's see underneath. Oh, wow, look at that.
Yeah, these are forged. They're a lot piston. They're
Let's
a
see the
lot
other one.
stronger
Turn the
material.
stock piston over.
Well, they're just cast.
Oh, yeah, look at that. Wow. Boy, big difference there.
But they're made to go in a stock rod. See? Everything stock application. They fit in. You know, the clearance. It's a modern design, so they're, you know, you run them a little bit tighter than normal.
You think the quality of the aluminum's better?
It is better. It's
For
forged.
75 years difference.
Yeah, well, this is cast and this is forged.
Well, I was going to
Big
say,
difference.
God, they're beautiful. Yeah.
Now this is made for 2815 bore,
Hard to see.
so 2.48 is stock. So that's 65 thousandths over is what these are for.
Okay.
So these are for some used cylinders. So this motor here, these were 70 override here. So these are probably fitting these.
So there's actually, as stuff wears out, works to your advantage, correct?
More than likely, this set here was made for the cylinders.
Is that a true statement?
What?
Well, cylinders that are worn out, you go with bigger custom-made pistons and...
Yeah, but at some point you get real thin.
Well, at some point, but nonetheless, you're building a race motor here.
But the customer has the option of whether we use a bigger bore, and you sacrifice the strength and the heat buildup versus getting a set of cylinders that has a smaller bore or sleeving them. So I was working on putting hardened sleeves in these things, but that's a large expense because I'm actually going to cut them way the hell out to here, put big oversized sleeves in here.
Right.
And then you put the seats on top. They go into the sleeve on this side, and all this stuff gets welded together, so it's strong. It's stronger than stock when you're done because the sleeves you put in there are a lot stronger
than the casting, sure.
They're probably 3 times stronger material-wise, so that means they can be a third the thickness for the same strength.
On the skirt,
Or after you put the metal back in, the little small amount you're adding back in, it'll be just as strong. It'll actually be a little bit stronger than if the whole cylinder was completely new.
Okay. All right, so you're just
so that's what that's going to be.
Better
And
engineering.
on the top end, I haven't perfected the dome part yet, so that's why I haven't played with it yet. So this here is the custom dome cut I made, and I'm figuring out how I'm going to make things. So this has your valve goes in there like that. See, this one's not made for this size very well. It's made for a smaller one like this one. So you got more clearance around it. But even that can be changed. You can run this big one like this in there. And the way I was planning on doing it, I was going to run something big like this one in this one.
And you're filling this up here, filleting this in?
Yeah, well, it's all been filled in.
Okay.
But see, the advantage of the dome piston is, see, the valve, air comes right across here, and you're right straight across, and then it goes in the motor.
Right, into the combustion chamber.
Right, so there's no steps or anything.
Right,
So
smooth for airflow,
So the air goes up, flows across, and it's into the motor. So I haven't run a dome piston motor yet. I've been dicking around with flat tops like this that you got an air dam where they hit them. You go into you angle cut these things trying to get stuff to work better, but.
So you think that's your next thing there was a dome piston, huh?
Yeah, well, Harley went to dome in '68 and 9 on the race bikes the last 2
All right.
years.
Well, why didn't you go with some type of dome on these then?
Because I haven't perfected it yet, and I need to get the job done.
Okay, just asking.
So this is what your head looks like stock.
Wow. It's a lot different, huh?
Now, the valves, these are the street valves. And see how they almost fit in the street head. See, the exhaust actually fits in there pretty good. The intake barely fits. So I can actually put these big valves in there and not cut the head out any.
And not mess with the head.
Well, I have to go in here and square cut the base so the valve will fit all the way to the top.
Right, right.
And I might have to cut deeper here depending on our valve lift.
Well, is there enough material in a stock pair of heads?
Yeah, these are pretty thick. So
Okay,
you're good.
and those are stock.
But you can't put a dome in here.
Do you like aftermarket cylinder heads or are they junk?
I like stock stuff better.
You like stock better, okay.
You know, this is one that's been modified.
Oh, shit. You just filled it all back up and start again.
I can do whatever I want with this one.
Wow, that's a stock head?
Yep.
Do you notice any warping by doing that much welding on a stock
It
head?
doesn't matter, I'm remachining it.
Okay, for flatness.
Now,
I got you.
What you don't notice is that this is now that thick. If you go back in my videos, you'll see I actually cut a hole all the way through the head, and then I backfilled it.
For strength.
So now the head is, you see the aluminum right here? It's the height of this bolt boss.
Uh-huh.
That bolt boss is an inch thick. So this head right now is an inch thick right here. The stock head is only about 300 thick at most, about that much. So you can't go in here and cut this dome in here and be a 300 thou dome, you'll cut through the head.
Right, because there's nothing here to go.
So that means you have to weld the head out.
Wow.
So you either got to break all these fins out of here and weld it from this side, or you cut the bottom of the head out here
And then fill it.
and then backfill.
Jesus Christ.
So it's easier to do it that way than weld all these fins back up.
It's kind of ugly looking,
Now
but
this here was a broken head, so I had to fix I did a bunch of fin repair on here.
yeah.
So, and I'm also maybe going to modify the spark plug a little bit.
Yeah, I see that. Completely welded it up.
We're going to go to a 3/4 reach spark plug here, so that's full, thicker. See, I just filled it from here to here, just solid.
Right. I see.
And I'm also going to go to a smaller diameter plug. You see how the stock heads, they crack right through here? See how they crack from heat?
Mm-hmm.
They start cracking this way and they crack through here too.
So you get a better plug for a newer performance
So
plug.
after I weld this head all up, it's just like the piston material. This is a lot stronger material that we're using here.
Right.
And so I get a really good strong material. And if you buy a new head, they're actually thinner than stock in a lot of places.
They are.
Some places. Other places are just about the same. Other ones are thinner. They're not made for performance. So to do this kind of stuff, to run a dome piston, you have to do this. So that's a lot of work doing that. But you get what you get. This is our dome piston right here. So this is what we're working for on our flow. Actually, there's this direction. So that's your combustion chamber shape when the cylinder's all the way up.
That's pretty high combustion, isn't it?
And you run this thing right up within 30 thou of hitting it.
And what kind of gas would you run this on?
Premium.
Premium.
It's going to be high compression.
But it'll run on pump gas, is what I'm saying.
Yeah, you got to have good pump gas. So that's what we're going to do. So that makes a real good design. This one over here, we're going to run a little bit of a pop-up. Well, actually, no, I'm going to be flat. I forgot. So instead of having a cutout like this, there's actually going to be a shelf going across here like this. And it actually goes this direction. So this will be flat from here over, and then you're going to have an angle wedge in here. Well, this comes in at an angle right through here.
Mm-hmm.
And it's kind of more like a stock head's doing it. See how they got this angle wedge in here?
What kind of compression do you think you're looking at?
But instead of doing an angle like they got it, you're going to do an angle, the intake's cut away. So it's going to be cut more on an angle like over here. And the angle will go this direction.
Mm-hmm.
And that's how you do it on the race bike. I don't know. It'll be over 7 probably. Might be 8. I don't know.
And what's it stock?
Stock, it's with the stock military heads is like 5 and 5.2 to 1.
Okay.
The high compression head will get you roughly about 6 to 1. That's as high as they get. So anyway, this is all the stuff we're doing. So that's basically where we're at. So right now we're going to do. I got to pull out the 2 motors. We got to get all the parts set aside. Make sure I got the valves and the pistons that we need for that application. Get everything lined up for both motors. See if I got all the parts. I haven't made the crank stuff yet, so I got to do all that.
These are 2 customers' motors?
Yes. Here's the races, a new set of Jim's races. I have to modify these and cut them.
Boy,
I'm going to put tapered bearings. I'm going to put roller bearings in here, which is this stuff over here. Now this is panhead stuff, so it's going to be smaller for the 45. That's why I don't know exactly what I'm going to do yet. Here's your thrust bearings. So these are going to ride right on the case races here. So I have to cut these in a lathe, cut this groove out. So I got to narrow them up to that point, which makes it flat, but also gives me room to put this stuff in there. And then we're going to run the bearing right on this surface. Then we're going to have a heat-treated thrust washer that goes on that, and this will go up against the flywheel to protect the flywheel. And then we have the thrust washer to adjust the in-play also.
Mm-hmm.
And I'm going to have to make up an adapter to go from the main shaft up to this diameter to hold this stuff, so it doesn't just wobble around in there. So that stuff I have to make. I don't know what I need for dimensions yet. I think this is probably the bearing size I'm going to use, because it seems like it's the right one. And so I have to make all this stuff up, figure out what I'm going to do, and then order up the missing pieces I don't have. This is the bearing off the big twin motor. See how much bigger it is?
Yes.
So I do this on the 54 and earlier motors, 36 to 54 motors. I put these in. That allows you to run a belt drive without tearing up the crank. It also gives you more horsepower because the crank's not eating itself up inside with thrust washers. All of this stuff has to be engineered yet. I haven't done this part yet. So I was trying to do a Timken conversion, and then the Timken, nothing moves. It stays put. You don't have to worry about it. But the cases are so thin over there, and it's just going to be too much for now. So I'm just going to drop back and do it the old-fashioned way that works. My 1935 bike has this kind of stuff done to it back in the 80s when I built that motor, early 80s, late 70s. And worked pretty good on that bike. So we're just going to continue the same deal, and it'll work fine on this bike. And yeah, we'll be good to go.
Sounds good.
It's just a matter of making it. Then whenever I pull my military bike motor apart, I'll be doing upgrades.
All right,
More than
so
likely, I'll probably never pull that motor apart because it's lasted almost 40 years already, and it's probably good for another 5 or 10 more.
yeah, but you said only 2,500 actual miles on it.
So I'll go ahead and probably build up a new motor, make another bike that's faster with all the upgrades.
I'll bet a little old private rode that bike, probably never rode it very hard.
There's no reason to take that motor apart, it still runs good.
Gotcha. Gotcha. Pretty nice.
So anyway, that's where we're at. So a couple more days, we'll start pulling all this stuff out, and we'll see what we got to work with.
Okay, get started on it.
There you go.
All right, cool. Wow, that's pretty neat.